Hello all. Today we will be learning about support vector classifier, and in that specifically maximal margin support vector classifier. Our dataset today is called as the iris dataset. It has four attributes: sepal length, sepal width, as well as petal length, petal width. The data has been collected for three classes. That is, those are the iris species. They are called as iris setosa, iris virginica, as well as iris versicolor. So now we plot the information about iris virginica and iris versicolor on the graph. For our lesson today, we are just working with these two species. On the x-axis, we have sepal width. On the y-axis, we have sepal length. The red circles, they mean that the point belongs to iris virginica, that is class A. The blue squares, they mean that the point belongs to iris versicolor, that is class B. So now we have created a graph here. The graph is, so it is a two-dimensional graph. So we have x and y-axis only. So suppose we get the information about a new flower. So we get specifically its sepal width and sepal length, and we plot it like this here. Now we want to find out to which class will this flower belong to, which species. So how will we solve this problem? Intuitively, you might think that we can just draw lines in the space that lies between these two classes, and then with that we can try to figure out to which class will the new point belong to. And if you have thought of that, you're absolutely right. So like this, we can just draw random lines that lie in between the space between these two classes. In the context of support vector classifiers, these lines, they are called as hyperplanes. What are these lines called as? The hyperplanes. So any point, so if we consider specifically this hyperplane, any point that will be to the right of this hyperplane, it will belong to class A. If it is to the left of this hyperplane, it will belong to class B. If we consider this line, any point that is above this line, it will belong to class A. If it is below this line, it will belong to class B. So just to give you some basic information, in a support vector classifier, there is only one hyperplane. We don't have multiple hyperplanes. So now the question arises that, so it's just easy. It looks very easy that we can just draw random lines and just try to figure out with that. But it's not that easy. If we consider a point that lies somewhere here, this classifier will classify it as class B, whereas this classifier will classify it as class A. Thus, the positioning of the hyperplane is paramount. What does maximal margin support vector classifier say? It says put the hyperplane right in the middle. So in the case of maximal margin support vector classifier, the hyperplane is put right in the middle, and it is called as the optimal hyperplane. What do I mean by right in the middle? In the middle, we are trying to maximize the margin. What is the margin? The margin is the distance of the hyperplane from the closest points, and these points, they are called as support vectors. So we are trying to maximize the distance from the support vectors. For our example, this one and this one, as well as this point and this point, these are the support vectors. So since our test point, it lies to the left of this line, it lies below this line, thus it will belong to class B. So the question arises, what will be the equation of this line? Just simple. The equation of this line is W transpose X plus B equal to 0, where B is the bias, X is the input data, and W is the weights matrix. Suppose if we get the information about a new point and we want to classify it. So what we will do, we will just put that information here in this equation. And if W transpose X, so X is the new data. So W transpose X plus B, if it is greater than 1, then it will belong to class A. The point will belong to class A. If it is less than -1, then the point will belong to class B. And also one more thing, since we are working with 2D data, the hyperplane is a line. If the data were to be 3D, the hyperplane would be a plane. So today, we have learned about hyperplanes, margins, support vectors. If you have any questions, please do feel free to ask me. Thank you. Thank you so much.